Hi, Year 10 and 11. Today we are going to be having a look at 9G, the radian measure of angle size. So previously we've looked at angles in terms of degrees. How many degrees is in the angle is the size of the angle, but we can also measure an angle in terms of another measurement called radians. Radians is actually generally used more often than degrees. And it's really important to know how to convert between degrees and radians and feel comfortable with that. Now, our notes are here, and we will look at these examples in a second, but I'm going to jump across into the OneNote down the side where it says radian measure of a size of an angle, and we're going to have a look at the notes in there. So I like these a little bit better. So imagine we had a circle of center 0, and we've got two radiuses drawn into that circle, and the radius is of size r. Now, what we can think of in terms of finding the size of the angle AOB, so our angle in the center here, is it's basically the ratio of the arc length AB to the radius OA, if we want to measure in radians. And that would be if we were measuring in radians. So I just want to show you how to come up with the radian measurement for 360 degrees, 180 degrees, and 90 degrees. And then you can decide if you want to memorize how to do it, or if you want to just memorize the size of the angle. Okay, so think back to earlier on in year 8 and 9 when we worked out the circumference of a circle, and the circumference of a circle was equal to 2 times pi times r. So in one revolution of a circle, our arc length is 2 pi r. I'll put that down there. So in one revolution, we've got 2 pi r. And the radius of that circle is r. So if I was then to cancel out my r and my r, I've got 2 pi. So 2 pi is equal to 360 degrees. So one revolution around that whole circle is also equal to 360 degrees. It's also equal to 2 pi. Okay, that's our first one. Secondly, let's imagine we had half a circle. We're going to again have a look at the arc length divided by the radius. So we know our radius is r, but our arc length in a whole circle is 2 pi r. So our arc length in half a circle is half of 2 pi r, which is just pi r. So in half a circle, we might highlight that up here. So in half a circle, we have pi r divided by r, so we actually have pi, and that's 180 degrees, so they're equivalent. Okay, so 2 pi is equivalent to 360 degrees, pi is equivalent to 180 degrees. We might just highlight that first circle up here to show us what we were doing. Now, imagine we were in a quarter of a circle now, so we're at 90 degrees. So let's think about what that is in terms of the circumference. So if we again had 2 pi r for a whole circle, pi r, that's half of a whole circle, for half a circle, a quarter of a circle, we've got half pi r as the whole distance around. If we divided that by r, we get half of pi, or just pi on 2, and that's equal to 90 degrees. So that's where the conversions come from. But if I just jump back up here, here they are, and this is what you need to know. We need to know that 360 degrees is equal to 2 pi radians, 180 degrees is equal to pi radians, and 90 degrees is equal to pi on 2 radians. Probably the easiest way, rather than remembering all of them, is to remember this one, or remember this one, and then we either double it or we halve it. Either way works for us. But you will need to remember those conversions. What we are then going to need to do is to know how to easily convert between degrees and radians. So to convert from radians to degrees, I multiply by 180 degrees over pi. To convert from degrees to radians, I multiply by pi over 180 degrees. So the thing that I'm wanting to convert to, basically the top line. So if I'm in degrees, if I want to convert 2 degrees, the degrees is on the top. If I want to convert to radians, then my radian or my pi is on the top. And we can work out what 1 radian and 1 degree is if we like. So 1 radian is 180 degrees divided by pi. So 1 radian is actually 57 degrees 18 minutes. And 1 degree is pi divided by 180, which is 0.0175. So we can easily work those out. These we can work out from these 2 bits here. So these are the bits that you need to remember, okay? And we can now use that to solve some questions. And we might just jump back into our topic notes to do that first. Okay, and it's got all our information on there that we've just looked at. We've just worked out that 90 degrees is pi over 2, 180 is pi, and 360 is 2 pi. And so we can work out what 270 is by combining our 90 and our 180 by adding those together. Okay, so let's work out these. Example 1, express these angles in radians or degrees. So if they're in degrees, we're going to radians. If they're in radians, we're going to go to degrees. Okay, so what I've just popped in the OneNote there for us is the rules. So to convert from radians to degrees and degrees to radians. So we'll use that while we're getting familiar with what we need to do. So the first one, 60 degrees. So we've got 60 degrees and we want to go to radians. So we're in degrees. We want to go to radians. So we're going to multiply by 1 pi over 180. So if I'm timesing that by pi over 180, I'm going to have pi on the top line. I'm going to have zeros cancel out. 6 over 18, 6 threes are 18. So it becomes pi over 3. Likewise, in B, we want to change 495 into radians. So 495 times pi on 180. My pi is going to stay there. I'm going to put 495 into my calculator over 180. And it's going to give me an 11 over 4. So I'm going to have 11 pi over 4. As a rule, we would leave it in this format with the pi in there. Okay. Now we want to go from radians to degrees. So let's have a look. Radians to degrees, we're going to be timesing by the reciprocal of what we times by before. So we've now got the 180 on the top and the pi on the bottom. So pi over 6 times 180 over pi. And what you'll notice when we're going back to degrees, the pi's are going to cancel out, which is what we want to have happen. And 180 divided by 6 gives me 30 degrees. So I'm just simplifying that down. So again, let's go to degrees. 3 pi over 4 times by 180 over pi. These guys cancel out. Again, you're going to probably need your calculator for this. So 3 times 180, divide that by 4, and we're going to get 135 degrees. So that's fairly straightforward. Okay, so before we do the couple of examples on our formula sheet, I'm going to jump into the textbook and just have a look at a couple of easier ones. In the textbook, we're looking at example 14, so we're still in 9G. Evaluate these trigonometric ratios using special triangles, using these special triangles shown. Now remember these special triangles that we're quite familiar with a few topics ago when we looked at trig functions. You will be given this triangle here and this one here on your HSC formula sheet. So let's go and have a look where it is. And you've all got a copy of your HSC formula sheet at home now. It is, oops, over here. There's our first page. It will sit on our second page. I've got them in green. They're given to you. Okay. So they're called special triangles, or I've often referred to them as exact value triangles. So we will be using that today to work out the next couple of questions. So if I jump back in here, so there they are again. Sometimes they might be flipped the other way, but we're looking at that today. So looking at A, sine pi over 6. Okay, I would do exactly what the textbook's done here, and I would think of, well, pi over 6, let's change that to degrees. Okay, so we're going to be timesing by 180 over pi, or you might actually get into the habit of just replacing that pi there by 180 and going 180 divided by 6, and I end up with 30. So I'm looking at sine 30. What is sine 30 in my special triangle? Sine, think of soc r toa, it's opposite on hypotenuse, so it's a half. So that's a nice and easy one. Okay, cosec pi over 4. Now, we need to think of what cosec was. Do you remember cosec was the inverse of sine? So cosec pi over 4 is 1 over sine pi over 4. What's pi over 4? We times that by 180 over pi, or just replace my pi with 180 and divide that by 4, and I get 45. So 1 over sine 45. We're going to use our triangle over here. Either of the 45 works. So sine, think of soccer, toa, so is the SOH, opposite on hypotenuse. So we've got 1 over root 2, but that's on the bottom line. It's 1 over root 2, which is just root 2. So those are fairly straightforward. Let's go and have a look at the ones in our notes that are a little bit harder than that. And we're looking at sine of 5 pi over 4. Now, I think to make it a little bit easier, let's change our 5 pi over 4, okay, to degrees. Now you can times by pi over 180, or the easiest thing to do is actually just replace our pi with our 180, okay, and see what we've gotten. Pop that into your calculator. So 5 times 180 divided by 4, I end up with 225 degrees. So what I want to work out is sine of 225 degrees. Now, what do we remember about this? We remember all stations to central. Do we remember that? We're starting here. We're going that way. We're at 0 degrees here. We're up to 90. We're at 180. Our 225 sits in here. Okay, so all the way around there is 225 degrees. What we want to think of is what this smaller part in here is. Okay, so what's that amount in there? We've got 180 and we've moved on. How much further than that? We've gone 225 minus 180. So that little bit in there is 45 degrees. I'll just write that in there. So that's 45 degrees in there. And what we want to work out is sine of 225. But we want to look at all stations to central. What is happening with sine in that quadrant? It is negative. So we're going to work out negative sine 45 degrees, which is negative. Let's think of those special value triangles again. Sine of 45, let's jump back to where they were in our textbook. Here they are here. Sine of 45, sine was the part of SOHCAHTOA, opposite and hypotenuse, so 1 over root 2. Jump back in there again. So minus 1 over the square root of 2. Okay, let's have a look at V now. Now, a couple of things, just to remind us, because I think we may have already forgotten, is let's jump back in and have a look what our radian measures were to remind us. So let's keep reminding ourselves. Pi is 180. That's what I like to start with. I know if I need half a pi, it's pi on 2. If I need 360, I double it. Okay, so what we're going to be doing is we're going to be changing our 11 pi on 6 for our sec of 11 pi on 6 into degrees, because we're familiar with working with that. My pi is 180, so I'm going to have 11 times 180 divided by 6. Quickly plug that in your calculator and see what we end up with, and we're going to end up with 330 degrees. So I need sec of 330 degrees. Now, this is not straightforward because we don't have a special triangle for sec. What is sec? It is 1 over cos. So we've got 1 over cos 330 degrees. 330 degrees is bigger than a first quadrant angle, so we need to be looking at our all stations to central again. Okay, and what's happening to get to our 330, we've moved all the way around here to a line down here, and that's our 330 degrees. So what we've got left in that last little piece is 360 take away 330, which is only 30 degrees. Now, in this fourth quadrant, we've still got 1 over, and I want cos of 330. In that fourth quadrant, cos is positive. That's excellent. So our answer is going to be positive, but it's positive cos of 30 degrees. Now, cos of 30 degrees. Let's use those special value triangles again. Either on your formula sheet, so if you've got the HSC formula sheet with you, grab it out. Otherwise, I'm going to jump back into the textbook and have a little look at it there. Cos of 30 degrees. We're working in the other triangle now. Think back to SOHCAHTOA. The cos is the part, which is adjacent and hypotenuse. So I've got 30 degrees and I want the adjacent and hypotenuse sides. So it's root 3 over 2. Let's jump back in to our page here, which is 1 over root 3 over 2. I can't have that fraction on the bottom, so it's going to be times by it and flip that upside down, so it's 1 times 2 over root 3. Okay, now those are the only examples that we've got there for now. What I want to have a look at is your calculators. So if you can grab your calculators and have those in front of you. I'll just see if I can find mine on the screen here. So I've got the abacus up here. All calculators will be very similar, but what we've been working from all the time is a calculator in D mode or DG mode. So that's our degree mode. That's what we always want to be in unless we pop it into a statistical mode or we pop it into a radian mode. Now, we can put these calculators into a mode that calculates radians. However, we need to be very careful that we know that it's in that mode and we want it to be in that mode. Otherwise, it will get all our other angles and degrees and everything incorrect. So we need to be very careful. So let's have a look at popping that into a radian mode. Okay, so what we want to do is have a look. If we just press that mode button, it doesn't give us the modes that we want. We don't want comp, stat, or verify, but above the mode button, there's a setup button. So if we were to press that second button and then our mode, what we're going to end up with are the various different modes that we can work with. We generally work with DEG, which is 3. If we were to press 4, we go into rad mode. So let's do that. And then what happens is our calculator changes our DEG to R. I will then show you once we have a little go at this how to get it back out of that, because this is very important to know how to get back out of that mode, because I don't want us working in R mode unless we really, really want to. So I'm going to jump into the textbook, and what we're going to have a little calculator are some of the questions. So we can evaluate questions where we're given a radian. So for example, this one here, it says evaluate correct to 4 decimal places. Cos 1. So cos 1 in radian mode is going to be equal to, I'm in my R mode, I'm just going to be pressing cos, I'm going to press 1, I'm going to end up with that decimal, which they put there, 0.5403, and we can, example, calculate cot of 1.3, which would be 1 over 10 of 1.3. Unless we want to, we're not going to do it that way. I just want you to be aware that it is possible. But what I want you now to do is to get your calculator back out of that mode. So we can either, I guess, do the setup and go back into mode 3, which changes it to degree. That's the easiest way. The other way that I show you often is above that 9 is a clear button. So if I just press second and 9, it'll reset everything back to factory settings on the calculator. So if I press 3, it'll reset all. Do I want to reset all? I'm going to go yes, that's equals, and just press the AC button, and that takes that back as well. If there's anything you're worried about, that's probably the best way to work that through. So that'll give you enough ability now to work through 9G. The first couple are very simple. You're going from radians, degrees to radians, and then radians to degrees. Definitely have a go at some of those to make sure that you feel confident doing that. And then we're going to, it's going to get you to put your calculator in radian mode to calculate these. It's probably just good to have a little go at getting in and out of radian mode. Use your calculator to express these angles in radians. I would prefer if you can do that algebraically by multiplying by pi on 180. I would prefer that. Then I want you to go down and using your special triangles, work out these solutions here. I don't really need you to do 13 and 14. Up to 12 is enough. If we jump back into our OneNote, you will see that in 9G, I've just popped on the schedule 3 to 11. I'd probably have a go at a couple in 1 and 2 as well, and I'll pop that in.